Hi guys, sorry I couldn't be with you today. Hi guys, today we're gonna start learning about X and Y intercepts, so make sure your tracker's up to date. Keep an eye on your 7 Renaissance objectives in the green program online, and make sure that you're checking your keys so far on the first 2 slope assignments. So on assignment 2 here, which was your first actual assignment, the key was on JT Learn on I think the date 2/1, and then the second one that you did in the last class, the key was on the back. So make sure you're checking the keys because you want to make sure you're getting signs right. If you're making sign errors on your slope practice, it's going to affect a lot of things when we get to writing equations. So if you're making mistakes, be sure to ask me or one of your seatmates to get that cleared up. All right, so get your tracker filled in for your Intercepts notes and your Intercepts assignment. And you can pause this anytime you need a little more time, and let's get started. So on the first side of your notes here, you've got 4 graphs, and all we want to do here at the beginning is just identify the intercepts. So intercepts are places where graphs hit the X and Y axes. So an x-intercept always looks like an X coordinate with a 0. It crosses over the x-axis, and the X value is 0. Okay? A y-intercept hits the y-axis. So it'll always have a coordinate 0 with a y number. It crosses the y-axis and the x value is 0. So it's important to know that in order to be an intercept, one of the coordinates is always going to be 0, and it's the opposite coordinate. So x-intercept, y will be 0, and for a y-intercept, x will be 0. And the intercept will be the actual number where it hits. So let's look at graph 1 here. This is an intercept on which axis? That's on the y-axis, right? So that y-intercept, what would the coordinates of that y-intercept be for graph 1? You can go down and write it on the table. Hopefully you're coming up with coordinates of 0, 4. Sorry, 0, 4. And then for the x-intercept, you've got, hits the x-axis right here, and that looks like coordinates of 2, 0. All right, so let's look at graph 2. This intercept right here is hitting the x-axis, and the coordinates of that point are -4, 0. Hopefully you can stay a step ahead of me on these notes. And the y-intercept, where it hits the y-axis, is right here, and that would be the coordinates 0, -3. So often when kids are talking about zeros, they accidentally reverse the numbers when they're labeling coordinates, so you've got to be a little bit careful about what you're doing. So see if you can write down, pause the video, write down the coordinates for the X and Y intercepts on graph 3 and graph 4. All right, hopefully you came up with -2, 0 for this one, and 0, 4 again for this one. And then for graph 4, it didn't have an x-intercept. It never hit the x-axis, so there wasn't one. And the y-intercept was 0, 2. So what we want to notice about the y-intercepts is that all the x coordinates are always 0. That matches what we said down here. And for the x-intercepts, the y coordinates are always 0, which matches what we said down here. That's just the definition of intercepts, so you want to make sure you're solid on those. You can easily see them on a graph, as long as you don't reverse the coordinates. All right. Oh, that's a funny hairstyle. All right. So how to find x and y intercepts if you don't have a graph? we're going to use that 0 knowledge that we have to find those intercepts. Okay, so we have to think, if we want an x-intercept, y equals 0, right? So we're going to put that in for y. So we'd have 3x plus 2 times 0 equals 18. Well, 2 times 0 will always be nothing, so that goes away. So we get 3x equals 18. So divide by 3, x is going to equal 6. So the coordinate of that would be 6, 0. All right, so if it's an x-intercept, remember the y-coordinate is 0. Now if it's a y-intercept, what's going to be 0? Hopefully you're thinking that means x equals 0. So we'd have 3 times 0. We plug in x being 0. That will force y to be the y-intercept of the equation. Because when x is 0, we'll find out what y is going to be at that point. So this makes nothing. So we'd have 2y equals 18. So then when we divide, we'll get y equals 9. Now just make sure you write your coordinates correctly. So that's 0, 9. The 9 is the y, so you have to make sure you write it in the right place. So what we remember from before is that if it's a y-intercept, x is going to be 0. So we plug that in, and it's x is 0 in the final version. All right, so go ahead and see if you can find the x and y intercepts of the next two there. Pause the video, see what you can do, and then I'll show it to you. All right, so for an x-intercept, y is 0, so that's going to go away. So I get negative 2x equals 10, so x equals negative 5. So I'd get negative 5, 0. For the y-intercept, x is going to be 0, so that goes away. I end up with 5y equals 10, so y equals 2, so I get 0, 2. Now I'm doing shortcuts here. You should show your work and make sure you're accurate. So for this x-intercept, let's see, so the answers were 0, 2 for this one, and negative 5, 0 for that one. This one, when y is 0, negative 8 times 0 is nothing, so I get x equals 24, and I'm already done. So 24, 0, be that guy. And then for the y, when x is 0, I'd have negative 8y equals 24. So I have to be careful with my signs. So y equals negative 3. So 0, negative 3 would be my y-intercept. All right, so you want to make sure, ask classmates if you're not understanding any of this zeros stuff, because that's the very definition of an intercept. It involves a 0. How do you know if you have an ordered pair and if it's an intercept? Is because a coordinate is 0. Okay, so it's all about zeros, and you're putting 0 in for the other variable. All right. So now we're going to graph what we just came up with so that you can use intercepts to graph. If someone told you to graph this equation, well, we don't know a lot about how to put this equation on a graph, but we found intercepts, so we could use these intercepts to make a graph. So we got 6, 0 and 0, 9. So we had 6, 0 for the x-intercept and 0, 9. So 1, 2, 3, 4, 5, 6, 0 would be right there. And then 0, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 would be right there. So the graph of this line would look like this. You gotta do your work neatly, connect the dots and make it straight. So that one would look like that. It's a graph. It has arrows because it keeps going, but that's a picture of one part of the graph. So go ahead and see if you can graph equation 2. And pause this, and we'll check it in just a second. So for 2, our intercepts were negative 5, 0, and 0, 2. So we're looking for negative 5, 1, 2, 3, 4, 5. Negative 5, 0, and 0, 2. 0, 2. So our graph of that line, that equation, would look like this. So 3x plus 2y equals 18. 3x plus 2y equals 18 looks like this on a graph. And negative 2x plus 5y equals 10. Negative 2x plus 5y equals 10 looks like this on a graph. And we can figure that out just by finding the intercepts by using zeros. If you'd like to grab a piece of scratch paper, I'd like to show you a few examples from Renaissance in case you finish your worksheet early. If you'd like to just do your worksheet and check the key on that and make sure you're solid, then come back to this video to get some Renaissance examples. That's fine too. So whichever way you'd like, but here's some examples on how they do it in Renaissance. So look at this nasty equation. If it says find the y-intercept, that means I'm going to make x be 0. Okay, so I have this right here is going to be 0. So I would have 3y over 4 plus 3 equals 0 divided by 2 is just gone. So I would have negative 1. Now you guys have solved these before, so you just got to be confident with your steps. So we will minus 3 from both sides. Careful with signs. So now I have 3/4 y, or 3y over 4, equals negative 4. Then we want to clear the fraction, so we'll multiply both sides by 4. So we get 3y equals negative 16. And then we'll divide by 3. And we'll get y equals negative 16/3. And you might have to reduce that fraction, or they may show it in a mixed number, probably not, but they might. So you'd think, how many times does negative 3 go into 16? Well, 3 times 5 would be 15, right? So you'd have negative 5 goes in 5 times, and you'd have 1 left over. So that 1 would go over a 3. So here's the other option, 5 1/3. Because if I did bottom times side plus top, bottom times side, 3 times 5 would be 15, plus 1 would be 16 over 3, negative. So negative 5 1/3 is the same thing as negative 16/3. Now this one says find the x-intercept, so that means y is going to be 0. So this would look like 6x plus 4. So just make sure, whichever one it tells you to find, don't get rid of that letter. Keep that letter because we have to find it. So the other letter becomes 0, and then we'll just solve this like a regular old equation. So you get 6x equals negative 4. Got to divide. So you get x equals negative 4 over 6, which we would reduce. So that would be negative 2/3. So it would be negative 2/3 comma 0. This one would be 0 comma negative 16/3 if they asked for it as a coordinate. Okay, so x equals negative 2/3, or if they wanted it as a coordinate, it would look like this because it's the x. So be careful on Renaissance. They might give this one and then they might give this one. So you've got to pay attention to which one you have found. This one's real easy. If they say find the x-intercept and there's no y, then the y is not even a part of it. So y is 0. If there's only an x in it, hopefully you remember that this is the equation of a vertical line because there's only crossing the x-axis. So you just solve it, or your coordinate would be negative 4, 0. So if there's only one letter in it, then it's either vertical or horizontal, and you just solve it to find out what it would equal. So there's a little help for when you get to the Renaissance on intercepts. The first couple Renaissances are about slope. All right, so go ahead, if you didn't already, do the paper assignment first, check the key, and then you can work on wherever you are in Renaissance, whether it's slope or intercepts. Work well.